first things first, because this is going to be an annoying thing to do. Is this okay? So, you see these formulas here? You don't need to memorize them because this topic is not going to be on the test. It's not in the rules that I have to give you guys a test over this, only that I assess you over it, which is the homework packet. So as we go through these and you're like, I'm never going to remember this, you'll, on the ways that I'm assessing have you learn this, that's in your homework packet where you can use your notes. Do you guys see what I'm saying here? So don't get too bogged down in this is really hard. I promise we'll work it out, okay? Is everybody with me? All right, so the basic idea here is we are looking at inverse trig functions. We're only going to focus on these three. We're not going to worry about the other three. Okay, and so when we look at the problems that might be related to the inverse trig functions, what we first want to look for is which inverse trig function matches it, and then how do we kind of undo all of those things. And so we're going to have to think about, so all those trig functions have the a, which really is going to be a squared, right? Okay, that a is a constant, and the u is a function. So as we go through, when we look at these, what we're going to do is look at these with respect to a and u to calculate the integral. Okay, so when we look at this first one, a, which of these trig functions does this look like? Yeah, it looks like this one, yeah? Because it's something over just two things being squared. There's no square root in that denominator, okay? So we're going to be doing arctan here. All right, so as I look at this, I'm going to say the first thing I'm going to do is rewrite it with that a and that u being squared. So are you guys with me that 1 is equivalent to 1 squared and 9x squared is equivalent to 3x, the quantity squared? And heck, just for fun, couldn't we rewrite that 12 out front and put a 1 on the top just so that it really does kind of match that arctan function? Is everybody good so far? So as I look at this and I say, the first thing we're going to do, we're just going to identify what are a and u. And in this case, a would be 1, and u would be 3x, and du would be 3dx. And maybe I might take that last step and say dx is equal to 1/3 of du. And the minute I do this, I can say, well, the integral will be 1 over a arctan u over a plus c. Can I do that? We have one slight problem. Hold on. I'm going to hold on to that. So wouldn't this become let me write it that way. Does that make sense? Okay, so if we use our rule, we now have 12 over 3 times the integral of du over a squared plus u squared. Which gives me 4 arctan times 1 over A arctan U over A plus C. So that becomes 4. 1 over A is just going to cancel out because A is 1. Arctan of 3x plus C. Now, let's look at, we're going to do C next. All right. First of all, which one does this kind of look like? Let me see in orange. The third one, right? Okay, so this is going to be some version of arcsecant, okay? And as we look at this, the next thing we want to do is decide what are our A and our U. So, are you with me that 25 is really 5 squared? So A would be 5, and U would be 3x. Because we're saying that, so we're saying this is what's being squared. Mrs. Downer is the most distracting person ever. That's not true. Apparently she made Miss Lombardi jump. Okay. How are we on the A and the U part so far? They are essentially the constant that's being squared and the function that is being squared. Okay? All right. So, right now, I can take that square root sign and write that as u squared minus a squared. And do you mind if I put the 2 out front? And we're not done yet. We still have to do something about the x and the dx. You with me? Now, you guys, are you with me that we can say du equals 3 dx? And are you also with me? That x is equal to 1/3 u. Are we comfortable with those two things? And then what does that mean? Du over 3 equals dx. Are we good with these 3 things? All right, so let's do kind of like this ginormous substitution step, okay? So, I'm going to take the dx out and put du over 3. I'm going to take the x out and call that 1/3 u. I'm just going to let you guys look at that for a second before I do anything else. Being very slow and intentional with the way we're taking the time to write this out. Are we feeling okay? Okay, so now this 3 and this 1/3 kind of go away, and I actually have exactly arcsecant. So I have the 2 from the outside times, I'm doing the integral of something that equals arcsecant, so it's going to be 1 over a arcsecant of the absolute value of u over a. Plus c. We're almost done. Again, this is just restating that rule, and then we go fill in our u and our a again. So I have 2 times 1 over 5 arcsecant of the absolute value of 3x over 5 plus c. And the final answer of this is 2/5 arcsecant of the absolute value of 3x over 5 plus c.
Do you have a pencil?
How about an erasable pen? How are we feeling? With more practice, is this starting to feel okay? Maybe? Okay. All right. Let's look at this next one. This doesn't look like any of them, does it? And yet, I can't just take natural log, because I don't have it, like, the u du thing isn't going to work out well for me, okay? So we're going to kind of look at this and do, I'm going to kind of rewrite this as x squared minus 4x plus 4 plus 3. Is everybody okay? So far, am I allowed to do that? To split up that 7 into a 4 and a 3. Now, why did I do that? Well, the whole idea of these trig functions is we're looking for something squared, right? So I split it up into 4 and 3 because I know that that x squared minus 4x plus 4 is x minus 2, the quantity squared. So it's almost like completing the square. Now, it's pretty easy for me to see that my u is equal to x minus 2. Okay? To find my a, I have to consider that a squared has to equal 3. So what does that make a? Yeah, square root 3. And if u is equal to x minus 2, what's du? All right. So if I go into all my substitutions now, my dx becomes a du. My x minus 2 squared becomes u squared. My 3 becomes a squared. And does this look like one of my rules? Which was arctan, yeah? Okay, so this is equal to arctan, or 1 over a arctan u over a plus c. We still doing okay? All right, so what happens to my 1 over a? It becomes 1 over root 3 arctan of x minus 2 over root 3 plus c. And then I might say that's root 3 over 3 arctangent of root 3 x minus 2 over 3 plus c. We doing okay? All right. Okay. Thoughts on this one?
Looks like arc sine.
It looks like arc sine. Where it's 2 squareds being subtracted.
Oh, no. I guess if you brought the...
It's icky, isn't it? But it's not 2 perfect squares being subtracted. So like what's a versus, like a can't be a square root of 4y. Because of like the y and the, okay. All right, so far we pretty much hate this?
Yeah.
All right, so we're going to do a little bit of algebra here, okay? So let's do this. I'm just going to take that square root of negative y squared plus 4y and kind of write it at the side, because that's really what we need to do something with, okay? And would you guys be okay if I called this negative 1 times y squared minus 4y? Now, do you guys remember completing the square? No? Let's talk about completing the square. Sidebar. And I say, well, what is half of that negative 4? I get negative 2. But when I square that negative 2, I get positive 4. And our whole goal in doing this is to try to make a perfect square. Now, am I allowed to just add 4 like that? Did I add 4? It looks like I added 4, doesn't it? But that 4 is inside this parentheses that has the negative out front of it. Is this okay? So by putting this 4 here, I'm essentially taking this whole thing and I'm subtracting 4 from it. Am I allowed to just subtract 4? No. So how can I undo subtracting 4? On the outside, I'm going to write a plus 4. So that this negative 1 and this 4 are like a negative 4. And then this 4 is a positive 4, so I haven't actually changed the value at all. So what happens? We now have the square root of. Are you guys cool if I write this 4 at the beginning? I'm going to bring down the -1 as a minus sign. And then I'm going to factor that y squared minus 4y plus 4 into y minus 2, the quantity squared. So it didn't start out as a difference of 2 perfect squares, but by completing the square, it is now a difference of 2 perfect squares. So now, when I go look at this, this becomes 2 over the square root of 4 minus y minus 2, the quantity squared, dy. What would you guys like me to use as my a and my u?
Would 2 be the A?
A would equal 2. U would equal y minus 2. Because you use just whatever function is being squared. And what does that say about du? It's equal to dy. Okay, I'm gonna pull this 2 out front. So that dy just becomes du over the square root of a squared minus u squared. Now does this look like one of our inverse trig functions?
Yes.
So that would be arc sine of u over a plus c, which makes this 2 arc sine of y minus 2 over 2 plus c. How we feeling? Medium? Medium would put me at really, if you guys were at medium right now, I'd feel pretty good about it. Because I don't think this is easy. Let's put it this way. I haven't worked my examples on the next page yet, so I'm about to start flying blind with you guys. Completing the square, okay? X squared plus 6x plus something. And our goal is to rewrite this as x plus that same thing squared. Is everybody with me? So what do I know about this number? Well, when I combine it with the x, I get 3x, right? Or I get something x, and I'm going to do that twice. So it's going to be like x plus something times x plus something. And these two things are going to be the same number, right? And they're going to give me, combined, a 6x. Is everybody with me? What are they if they're the same number? 3. And if that's the case, what number would have been here so it factored out to x plus 3, the quantity squared? 9. So what you do, you always take half this number and then square it. Is this okay? So if I go back over, Does this fit any of them? Or I'll do this for you guys. Hold on. Does this one fit any of my rules? Not really, huh? What do you think we should do? Does anybody have an idea? It's gonna be one we kind of used the other day. Okay. Could I do x over the square root of 4 minus x squared dx plus 2 over the square root of 4 minus x squared dx? Could I split that up into 2? Now what? Do any of either of these and or the other one match any of these rules? Which one does it follow? Now with that x on top, it doesn't, right? What about the second one? Does the second one follow one of these rules?
That one follows arc sine?
Yeah, the second one, especially when you consider I can take this 2 and move it out to the front. Okay? The second one follows arc sine pretty well. So as I look at it, I might call this 2 times, and then u would equal x, right? And a would equal 2. So if I pull that 2 up front, and du would equal dx. So I'd have du on top, square root of a squared minus u squared, which is 2 times, if I take the integral of that, 2 arc sine of x over 2 plus c. Does that feel okay? Then what do we do about this first one? Okay, guys, we've been doing ones like these for a while now. It just feels different because we're learning it in a new context. But could we do u sub here? But instead of u sub, since we already have a u and an a, I'm just going to use a different letter for my alternate function. And I'm going to let y equal 4 minus x squared, which would make dy equal to negative 2x dx. Which means dy over negative 2 equals x dx. And boom, this x dx now becomes dy. I'll have 1 over the square root of u. And that negative 1/2 out front from the dy over 2, negative 2. And what's the integral of 1 over, well, that's just u to the negative 1/2, right? So if I bump that up, it becomes positive 1/2. And then I would divide by 1/2, which would be 2, multiplying by 2. So this becomes 2 times the square root of u. And I'll have that negative 1/2. So this just becomes negative square root of 4 minus x squared plus 2. You guys want to do one more, or do you want to do the last few examples tomorrow because you're fried? Last 2 examples tomorrow because you're fried?